Hey, in this video we're going to look at the L'Hopital's rule, and you can think of this as kind of like a shortcut that you can use to find limits that would be pretty hard to find without this rule. Okay, so two things you have to know is when to use this rule and how to use it. So for the when, you have to ask yourself, if you have a limit, let's say limit of x approaches something of something, if this is equal to 0 over 0 or infinity over infinity, then you can actually use this rule. So for the first step, evaluate the limit, plug in whatever number you have here into whatever you have here. If you get 0 over 0 or infinity over infinity, then you can use the L'Hopital's rule. So that's the first thing you have to know. Second thing is how to use the rule itself. So for the how, think of it as a fraction. So if you have the limit as x approaches a, so x approaches some number or some constant, and then for the actual limit itself, it would be, let's say, f of x over g of x. If you have this, and you have determined that this is equal to 0 over 0 or infinity over infinity, the way you would do this is that you would say that this is equal to, using the L'Hopital's rule, limit as x approaches a, this part stays the same, so yeah, x as x approaches a, of f derivative x over g derivative of x. So you basically take the derivative of the top and put it here, derivative of the bottom and put it here. That's literally it. Okay, one more thing that you have to notice is that we're not taking the derivative of the entire thing, because if you did that, you would be taking the quotient rule, which is some other topic which we're not doing. In this case, we're just taking the derivative of the numerator by itself and then the denominator by itself. And one other trick that you might have to do sometimes is that you might have to use L'Hopital's rule multiple times in the same question. So for example, if you use it once, but this is once again equal to 0 over 0 and then infinity over infinity, if it's one of them, it's completely valid to use L'Hopital's rule again. So saying this is L'Hopital's rule, and you get the limit as x approaches a of f double prime of x over g double prime of x. So we just did derivative twice. Okay, once again, you can use it how many ever times you want, and we are taking these derivatives by themselves individually. Okay, so let's actually start solving questions now. So yeah, moving on to question number 1. Okay, first example, we have limit as x approaches 0 of 2 plus x cubed minus 8 all over x. So if you plug in 0 into the x's, you'd have a 0 here, and if you plug in a 0 here, you'd have 2 plus 0 cubed is 2 cubed, and then minus 8 over 0. This is the exact same as 0 over 0. That means we can use the L'Hopital rule. Okay, so this is for your understanding. You don't actually have to show this. As long as you understand why we're using the L'Hopital rule, then you can just use it in general. You don't have to show this at all. Okay, but yeah, so if I erase these errors now, we can say that this is going to be equal to, using the L'Hopital rule, using h, this is going to be equal to the limit as x approaches 0. So once again, this part stays the same. We don't change anything here. And then the derivative of the numerator, what would that be? So the derivative of 2 plus x cubed minus 8 would be, so this is d over dx derivative. This would be 3 times 2 plus x squared, and then times 1, because you're basically taking the derivative of the outside, chain rule basically. So yeah, derivative of the outside times the derivative of the inside. So this would be 3 times 2 plus x squared, and then the negative 8 will go away because the derivative of that is 0. So that's the derivative of this. And then for the bottom, the derivative of d, the derivative of x, should be just 1. Because once again, that's how math works with derivatives. So pretty simple. And then let's actually write this down. So for the numerator, like we said, for this one, we can get rid of this times 1. It doesn't do anything at all. So I can write 3 times 2 plus x squared. And then for the denominator, all we have is 1. So 1. And then now it's pretty simple. This will be the same as the limit as x approaches 0 of 3 times 2 plus x squared, because divided by 1 does nothing. Okay, after that, plug in the 0 here. So if you plug in the 0, you get that this is 3 times 2 squared, which is 3 times 4, which is 12. And that is your answer, so we are done. Okay, pretty simple. Once again, small recap. All we did, you took the derivative of the top and the bottom, and you found the limit. It's as easy as that. Okay, let's move on to question number 2. Okay, question number 2. First, let's do the exact same thing. Let's look at what we have here and see if we have either 0 over 0 or infinity over infinity. Because once again, if you have one of these, that means you can use the rule that we are talking about here. Okay, so first, let's plug in x, like we said. So if you plug in x, you would have 3 times infinity plus 2 over infinity squared minus 4. If you actually evaluate this, 3 times infinity plus 2 is still infinity. That's how infinity works. Then infinity squared minus 4 is still infinity. So since we have infinity over infinity, we can use the L'Hopital rule here. So let's write that down. We can say that this will be equal to using the L'Hopital rule. And if you want, you can say infinity over infinity. That's extra knowledge, but it really depends on what your teacher wants. So make sure to ask them. Okay, and then after that, so yeah, using the L'Hopital rule, we can say that this will be the limit as x approaches infinity. And then what is the derivative of the top? The derivative of 3x plus 2 is just 3. And then of the bottom, so derivative of x squared minus 4 is 2x. Okay, after that, plug infinity in. So if you plug that in, you would get this is equal to 3 over 2 times infinity, which is the same as 3 over infinity, which is 0. Because we know that if you divide anything by infinity, the number becomes really, really small, which is basically 0. Okay, if you're wondering, what happens if at this point we had infinity over infinity again? What you would do is that you would actually use the L'Hopital rule twice. That is valid, it's possible, and you might see it. Okay, so once again, if you use L'Hopital rule once, but somehow you end up with infinity over infinity or 0 over 0 again, you can still use it as many times as you want. So it's not like you use it once for the question and it's done. You can still use it again and again if you need to do that. Okay, let's move on to question number 3. Okay, question number 3, which is going to be the last question of this video. Here we have limit as x approaches infinity of x times sine of 1 over x. So how do you solve that? Let's do what we usually do. Plug in the infinity into the x and this x, into both x's that we see. Okay, so if you do that, you would get that over here you would have just infinity, obviously, because you just plug it in. Okay, and then that would be multiplied by sine of 1 over infinity. Okay, so far so easy. All I did was I put infinity here and here. That's all I did. Okay, now let's actually try to simplify this a bit. We would have infinity multiplied by sine of 0, because 1 over infinity is the exact same as 0. So we can actually do this. Okay, after that, it's pretty simple once again. Sine of 0 is the exact same as 0. So this would be infinity times 0. Okay, before you say that you made a mistake, because if you remember the two options that we said we can use the rule were either 0 over 0 or infinity over infinity. If it's either one of these, that means you can use the rule of L'Hopital and find the derivative and whatever you want to do after that. Okay, but here we have infinity times 0. So can we use it yet? No. We have to do one small change, which you actually might see pretty often because it's a common trick, is that you might want to flip this infinity. Flipping the infinity is kind of, what I mean by that is going to be 1 over 0. Because we know that infinity is equal to 1 over 0. So rather than saying infinity, I'm going to say 1 over 0 multiplied by 0. Okay, and now if you actually multiply this, you would get 0 over 0. And now, since this is one of the options up here, we can actually use L'Hopital's rule. Okay, but the only change you'd actually do is that since we flipped the infinity, kind of, by flipped, I mean brought it down in some other way, we're going to do the same thing with whatever we had up here for the infinity. So whatever we had for the infinity, which was an x, we're going to flip that somehow to make it go to the bottom so that we can actually use L'Hopital's rule. Okay, so actually let's kind of do that. You would have that this is equal to the limit as x approaches infinity of sine 1 over x. So far this stays the same. I don't flip this. But then when you want to flip the 1 over x, you would put it on the denominator of the denominator. Because if you think about it, if you put it on the denominator of the denominator, it actually goes back to the numerator. So we're going to do that to kind of have it in the denominator of this fraction. So now I can say that this will be equal to, using L'Hopital's rule of 0 over 0, that will be equal to, we know that the derivative of sine of 1 over x is the exact same as, so first let me write the limit. So limit as x approaches infinity. But yeah, so sine of 1 over x will be equal to cosine of 1 over x times negative 1 over x squared. That is just the derivative of sine of 1 over x. If you have trouble finding this, watch my limit video or the chain rule video. I'll link that in the description. But that's basically the derivative of the numerator. And for the denominator, what is the derivative of 1 over x? That would be 1 over x squared with a negative sign up here. Okay, so far so good. I'm going to kind of bring this down so that we have space and it looks nicer. But yeah, so far we have this. Okay, now what can we do? Pretty simple. Cancel out the negative 1 over x squared from both the numerator and the denominator. And then you would have this as the limit of x approaches infinity of cosine of 1 over x. Okay, we're almost done because now it's pretty simple. But if you actually try to evaluate this limit, you would get that this is equal to cosine of 1 over infinity. And what is cosine 1 over infinity? It is the exact same as cosine of 0. And you can even put this on a calculator, but cosine of 0 is equal to 1. Okay, so we found the answer, and that's basically it. So quick summary for this question here. All we did was that we kind of manipulated the question so that we can have the option to use L'Hopital's rule. After that, we noticed that we need to flip the infinity, so we flip the x as well, bring it down. After that, you actually use L'Hopital's rule, find the derivative of numerator and denominator, and then evaluate the limit to get the answer. Okay, so it is pretty simple, but this is the hardest step here of finding a derivative, which you just have to do because it's part of the question. Okay, so make sure you also know how to find derivatives in a good way as well. Okay, but yeah, that's it for this video. Hope you liked it and hope you enjoyed, but drop a like if it helped you because it helps me as well. So yeah, that's it.